Can we go over problem 15 on homework 11?
So homework 11, number 15, do you know what that is, or is that out of our book?
It's the absolute value y minus 3 equals 8 minus the absolute value of y minus 3.
Okay.
And I think we're finding domain and range.
Trying to find
Domain and range.
domain and range. Okay. So we don't have a lot of experience with absolute values. I would add this to the other side. So an absolute value of y minus 3 plus another absolute value of y minus 3 is going to make two absolute values of y minus 3's. And okay, and then we can divide out the 2. And so we're going to get to the absolute value of y minus 3 is equal to 4. Now that's still not really clear what we've got here, but if we want domain and range, seems like an odd question for that one. Are we sure
I
that's?
think it's looking for like a solution to like what y equals.
That sounds better. So we can actually solve this. So what we do with an absolute value is, what's in here can equal either the positive 4 or it could be equal to a negative 4, and then the absolute value made it positive. So kind of the rule of thumb is when you drop the absolute value, you make that equal to the positive and negative of what's on the other side of the equal sign. Okay, so now we get two separate equations. So you get y minus 3 equals 4 and y minus 3 equals negative 4. And then these we can do. So we're going to get 7 is going to be one of them and negative 1. So there's two answers to this. Which is why if we were talking function, this wouldn't qualify because you have one input is going to give you multiple outputs when you see that absolute value around the y. Just kind of salt away in the back of your mind. That's not, I don't think, the question that was asked. Others? Other questions from any of the homeworks?
9 of homework 11.
Oh, okay. And do you know what that is?
We're trying to find a domain and range or something. I just don't know how we got the range.
Okay. Do you know what the original was?
No.
Okay. So let me. Anybody else know, or do you remember what page we're on there? 88. Okay, and we're doing number 9. So, okay, it's a piecewise function and they want domain and range. So we are looking at x plus 1 for x less than negative 1. And x squared plus 3 for x greater than or equal to negative 1. Now, the domain question here is not really complicated because it's telling you the domain right here. It's telling you the values of x that you can use. So this part of the function is going to use all the values of x less than negative 1. And this part of the function is going to use all the values of x greater than or equal to negative 1. So between the two of them, we got all the x values covered. So our domain is going to be, we say all real numbers, and you can write that with that symbol double bar r. So that's a set of all real numbers. The range is trickier because now we almost kind of have to think here. I think we're almost going to have to graph it to figure out what that range is. What y values are we using? And that's good practice, but these are tough. So that's a straight line, and it's got slope 1 and y-intercept 1, but I wouldn't use that. I would plug in the boundary point. So when x is negative 1, this y value wants to be negative 1 plus 1 is 0. So at negative 1, we want to be 0. Because of the strict inequality, you want to put an open circle. Now, we're using values of x that are less than negative 1. So I can plug in something that's left of negative 1 to get a second point so that I can connect them and get that line. So if I plug in negative 2, negative 2 plus 1 is negative 1. So at negative 2, we're at negative 1. And so I'm going to connect these two, and that's that part of the graph there. okay? Now I'm going to switch to this, which is a parabola. And this parabola we know opens up. And you may remember, we haven't talked about it, but the vertex is going to be, do you remember what the +3 is going to be? We're actually going to talk about this today. But yeah, so it's a parabola and it's going to move it up one. So the y equals x squared starts with the vertex at the origin, and the +3 is going to move it up 3. So its vertex is going to be at 0, 3. So we know that we are going to have 1, 2, 3. There's going to be the vertex. It's going to be a parabola that opens up. And I'm going to get all of this stuff. But then I got at the left, I'm going to cut it off at x equals -1. -1 squared is 1, +3 is 4. So that's going to be right there. And so that's what our graph looks like, which is really weird. Is that okay? Now, to get the range out of that, we have to think pretty carefully. So we're going to get the y values that are all negatives, but not including 0. Does that make sense? You see that visually, we're getting all these y values and all those y values up there, but we're missing all the y values in between here. So these are going to be y is strictly less than 0. And then these are going to go from 1, 2, 3 forever up. So that's going to be greater than or equal to 3. Okay, tough question. Others. Okay, so what we're going to talk about today is, we kind of talked about it right here already. We're going to talk about transformations of graphs, in particular shifts and reflections. You've seen that before in your Algebra 2 days, so hopefully we're just kind of brushing cobwebs off. And then we'll try to take a look at it in maybe some other situations that aren't as familiar, like piecewise functions, and we'll look at also what it looks like when the function is given numerically as a table of values. So this is 2.4, transformations. And we'll talk about shifts. Or these are actually also known as translations. So shifts are the same thing as a translation. What's going to happen when we move it to the right or to the left? So we know, I mean, we have done this before. So let's work a couple examples and then we'll formally write it down. So if we have y equals the absolute value of x minus 3 plus 2, with your fingers in the air, what does the absolute value of x look like? Yeah, good. So we're seeing a v. It's a v that opens up, and the vertex, the point of that v, is at the origin to start with. And so what does the x minus 3, x plus 2 do? What does the x minus 3 part do to that vertex? It's going to move it which direction? Actually, it's going to move it in the x direction and positive 3. Okay, it seems counterintuitive, but that's what's going to happen there. And what's going to happen with the plus 2? It's going to move it up 2. So you move it opposite of what you see in the x direction, same sign as what you see in the y direction. So what we get then is we go 1, 2, 3, and 1, 2, and there's going to be our starting point, 3, 2. There's going to be our vertex. Now, most of the time I don't care, you know, I'm not going to be really all that picky about, you know, how precise the rest of it is. When we start doing stuff like vertical and horizontal stretches and shrinks, which we will in the next few days, then I'm going to want you to plot another couple of points. But for now, I'm totally okay with just doing it that way. And you can label where the vertex is, because that's what we're trying to keep track of, is where it is, and then the basic shape of that. Okay, so y is equal to, we're getting the cobwebs off also out of some of these kind of graphs that we just have to know from memory. So we call the y equals absolute value of x is the parent function. So that's what we kind of start with, our basic shape, and then we say, what does this other stuff do to it? How does it move it around, change it? And we're doing shifts today and reflections, but we'll add in vertical and horizontal stretches and shrinks, which are a little tougher in the days that come. So with your finger in the air, what does the y equals x squared look like? Yeah, so that's our parabola that opens up, and it's got the vertex. That low point is going to be at the origin. And so the x plus 1 is going to move it now which way? Right, left, up, down. Left 1. So it's it's in the x direction, and it's the opposite of what you see. So the minus 3 moves it right 3. and the x plus 1 is going to move it left 1. And how about the minus 3 here? Up, down, right, left. It's going to go down 3. So our vertex that was at the origin is going to get moved left 1 and down 3. And so that's going to be at -1, -3. And we'll talk more about, what those other points are, but I'm not going to concern ourselves with it at this point. So it's going to be a parabola that opens up. Okay? So let's get the cobwebs off some other shapes. These I'm not sure if you're as familiar with. So let's do y equals the square root of x minus 2 minus 1. So with your finger in the air, what does the square root of x look like? Yeah, some people call it a swoosh. It's the top half of a sideways parabola. So it's not the whole parabola, it's just the top half. So, and then what is the x minus 2 going to do? It's going to move it up, down, right, left, which?
Left or right?
Right. And the minus 1 is going to move it up, down, right, left.
Down.
So we're going to go right 2 and down 1. And so it's going to start at 2, -1. And it's going to be that top half of a sideways parabola, or a swoosh, as some people have called it in the past. How about this one? You may or may not know this one. Y equals x plus 2 quantity cubed plus 2. So with your finger in the air, do you know the x cubed? You're doing more of a cube root, which is related but not quite the same. Yeah, this one is going to start down here and it's going to kind of swirl as it goes through the origin, but it's going to take off in a big way up and down. Okay, so the cube root is going to go more sideways, kind of like a big Z that's been stretched out. So our basic shape, so our parent function is going to look like that. So it's really long and tall rather than wide. Not that its domain is still all real numbers and its range is still all real numbers, but it's going to really take off vertically. So the x plus 2 is going to move it which way? Up, down, right, left?
Left.
Left 2, and the plus 2 is going to move it
Up.
up 2, so we go over 2, up 2. That's our -2, 2, and it's going to do that swirling action as it moves through there. Okay, so so formally we say that y equals f of x minus h plus k, or sometimes it's written y minus k equals f of x minus h. Either of those. This adding and subtracting of things in there is going to be a translation. So that's a translation or a shift I'll just leave it as that. So in the x or y. I'll say, I'll just write it as hk. So it's going to move it h in the x direction and k in the y direction. Okay? So we also know reflections from our past. So we can either have a y equals negative f of x or a y equals f of negative x. And people, these are easily confused, but we'll try to keep them straight. So when you multiply the negative x, so think, for example, like a negative x squared or a negative absolute value of x. What is the negative there going to do? Show me with your fingers in the air. Yeah, good. So yeah, it's going to reflect in the x-axis. And so the parabola would then open down. The absolute value would be a v going down. So that is going to be, we say, reflection in the x-axis. Now, it's a little harder to show this. We don't have as many functions that can really clearly show the f of negative x, because that's going to be a reflection in the y. So x squared and absolute value of x aren't very good examples of that because they're symmetric in the y-axis. So if you take a parabola and you reflect it in the y-axis, it hasn't changed. It's exactly the same. Same thing with an absolute value. So I think a better example is one like a square root of x. Remember, this is our top half of a sideways parabola. So now we can see more clearly what y equals negative square root of x is going to be, what that negative inside the function is going to do. So in our graph, you can show me with the finger in the air, what does y equals the square root of negative x look like? Go ahead, Aaron, you're reflecting in the x there. This is reflection in the y. You might have been right, Misha. What did you have? I didn't mean to. Yeah, you were right. Yeah, I was shaking my head because Aaron was not doing it. So yeah, the original looks like this. So when you reflect in the y, it's gonna look like that. Okay. And then we can throw it all together. You know, I mean, we can do the reflections, we can do the translations, we can do multiple reflections. So it gets more fun when you do something like negative square root of negative parentheses x minus 1 plus 2. Now you have to be a little careful because the way I have written it here where it's factored, you can see distinctly, you can distinguish between the reflection and the translation. If I had distributed that, it could have easily fooled you or tricked you. So as it's written, you can see that we're going to reflect in the x, reflect in the y. We're going to translate what in the x direction? Right or left? Right one. Now, if you looked at this, it would be it's easy to say, oh, I see the x plus 1. It's going to move it to the left one. That is not the case. So to distinguish, to separate out the reflection from the translation, you need to factor that out so that what you have here is as coefficient of x positive 1. So yes, this is not really unravel it. You can go ahead and put down what you think it is, and then I'll go show you what it really should have been. Just messing with you there. It's not that I don't have confidence in you. And the reflections can go in either order. The translation has to come last. So you can reflect in the x or y first, it doesn't make any difference. I'm going to try to leave a trail to show how you do this kind of in stages. So the reflections, I did the reflection in the x first, then the reflection in the y. You could have reflected in the y and then in the x. After the two reflections, you're still going to end up down here in quadrant 3. Then, yeah, now we're going to move it right 1 and up 2. Yep. So now, what color have I not used here? Purple. So now, and we can kind of keep track of this point as we go right 1 and up 2. And so that's going to be at the point 1, 2, and then it's going to have that shape down there in quadrant 3. It's going to look something like that. Okay? So we can now use this idea and now make even more complicated piecewise functions, which of course is more challenging. So let's see what we might ask you to do. Suppose we do the absolute value of x plus 3 minus 1 for x less than negative 1. We'll say negative x for negative 1 less than or equal to x less than or equal to positive 1, and a negative parentheses x minus 2 squared plus 1 for x greater than 1. So you have 3 distinct pieces there. And we're going to graph each one of those. We've got to be wary of where the boundaries are on that graph. So we need to know exactly what the y-coordinate is when we plug in negative 1 for x. Here we need the boundary points x equals negative 1 and x equals 1. What are their y-coordinates? And likewise down here with 1. Does that make sense? Okay, I'll give you a head start so you can try it. Feel free to consult, collaborate. And then I'll jump in after you've gotten a start on it so people at home can kind of see the process here, and we can talk about it after you've gotten a chance to put your best shot down. How are we doing? Agreeing a little bit? Should we talk about it? So on the first one, the x plus 3 minus 1, we know it's a v, because that's what an absolute value looks like. It's going to move the vertex to -3, -1. The stuff to the left, we don't have to worry about that. That's going to be fine. We got to know where we got to cut it off. It's going to end at negative when x is -1, and that's going to be with a y value coordinate of 1. So at -1, 1, we put an open circle, and that's where we chop our v off. Then we switch to this straight line. I'm just going to plot the beginning point and the ending point. So -1, 1 is a solid dot, which just happens to exactly match up with the open circle and fill that in. And then we get 1, -1, which is a solid dot here. We connect those with the line segment. Then we switch to the third one, which is a parabola that opens down and has vertex at 2, 1. So there's our vertex. This is going to go forever right of 1. So I know to the right of 2, it's going to be fine. The boundary point when we plug in 1 is going to give us a y coordinate of 0. So our parabola ends up stopping at 1, 0 with an open circle. And so we can see that there's a break in the graph there. They don't connect. So the first 2 parts of the graph connected. In the second and third parts, we have a discontinuity. It's called a break in the graph. Okay? I'm going to give you a different kind of problem. I'm going to give you questions on this at all. Okay, and we'll try to come back and do some more. We'll see how our time goes there. But I want to do some with functions that are given numerically, that is as a table of values. And we'll do some of this kind of translation and reflection stuff, which is a little different kind of twist than you may have seen before. So I'm going to give you x and f of x as a table. So the x values are going to go -2, -1, 0, 1, 2, -2, -1, 0, 1, 2. And the y values, the f of x values are going to go 5, 3, -1, 1, and 2. And our first challenge is, can we fill out the table as best we can with x and f of x minus 1. We're going to have to talk about this a little bit because I'm not sure you've done anything quite like this before. So I'll give you a moment to get this stuff written down, and then we'll try to see what we can do with this. Now, as you look at your table with the f of x, what you have to remember is this is all we know about x and f of x. So we only know the 1, 2, 3, 4, 5 values of x. Okay, we cannot plug anything else into f of x, as we move on down here. We're going to have to pick x's that when we plug them into here are going to end up evaluating that function at these 5 values. I can't end up trying to evaluate this at f equals -3 or f equals +3 because there is no definition of f there. I have no idea what that is. I can't assume anything about this table going beyond the 5 values that we know. So we're going to pick 5 x values that when we subtract 1 from them, give us these 5 values that we can then evaluate and get these 5 f of x values. Does that kind of make sense when we say it again? So for example, can I plug -2 into this for x? Can I plug -2 in there? No, because it's not defined. If I plug in -2, I have to go -2 minus 1 is -3. F of -3, I don't have. It's not defined there. So that -2 is not going to be in the domain of this translated function. See how the game's played? All right, you give it a shot. Sounds like you know what you're doing. Let's see if that's really true. So you fill out your table. No, you're not even pretending that you. Should we do it together? Okay, so what is of our choices here? What is the first value of x here? So we can kind of look at it this way. We're going to pick an x that when we plug it in here to x minus 1 is going to end up giving us a -2 to evaluate. And so that's going to be -1. Right? So if I choose x to be -1, what I actually evaluate is f of -1 minus 1, which is f of -2. That we can do because that's in the table. So when x is -1, we're going to get here f of -2, which we know is 5. Kind of weird? Yes, but kind of fun in a weird kind of way. Next value of x is going to be what? 0. Because when we plug in 0, 0 minus 1 is -1. F of -1 we know from the table is going to be 3. Okay? And the next one is 1. And we evaluate f of 0, which we know from the table is -1. And so we plug in 2. We evaluate f of 1, which we know is 1. And we plug in 3. Now it seems like it's weird, but we're going to be okay because we evaluate f of 2, which we know from the table is there. Okay, now, big picture, we take a step back, what we see is these values that occurred at these x values have been shifted, right? They've been translated in the x direction. Yeah, 1 to the right. Make sense? Okay, you say that now. Let's do x and let's try about f of x plus 2 minus 3. Oh, this will be fun. I'll give you a minute to try it. So decide first, what x values are you going to use? So what's the first value of x you're going to plug in there so that what you really take to your table, remember you got to go back to that white table.
Is that x plus 2?
That is clearly an x plus 2. The biggest challenge in here is going to be to learn to read my writing. That is clearly an x.
Thank you.
Plus 2.
It's a little small.
So you should end up with 5 x values up there when you're actually finished, and you'll have 5 different y values. What do you think, Misha? What's your first Misha value of x going to be that you're going to plug in there? You can pass if you don't know.
Wouldn't it just be -1? I don't know.
Well, if you plug, let's think about it. If you plug -1 in here, what you're really going to evaluate is -1 plus 2 is 1. You can evaluate f of 1. Does that make sense?
So what do I do with the -3?
We'll get to that first.
Okay.
Let's start, we want to try to evaluate there. Go ahead, Sage, help us out.
There's a -1.
It is -4. Because if we plug in -4, I mean, the -1 is gonna work. It's just not gonna get all, we're gonna have to back up to get these others here. When you plug in -4, then you're gonna get -4 plus 2, which you can evaluate as that first value there. And that value is gonna be 5. So that much, so what we're getting is that the f of -4 plus 2 is gonna be 5. That's this part right here so far. Now we're gonna take that 5, that y value, that f value, and now we still have to subtract 3 from that. And so what we get here is gonna be 2, because we're subtracting 3 from it. Right, so we're subtracting that 3. So it's going to be a 2. See how the game's played? It takes a little while. Okay, so Heidi, what's the next value of x we're gonna plug in?
-3.
Good call. And when you plug in -3, you're gonna actually evaluate f of -1, and f of -1 we know is 3, and then we're going to subtract 3 from that, so we're gonna actually end up with,
0.
oh, what a strange game this is. Is that okay? Next value of x, Katrina, what do you think?
-2.
Good call. And f of -2 plus 2 means we're going to actually evaluate f of 0. That takes us to the table, and we see that f of 0 is actually -1, and then we have to subtract 3 from that to get -4. Okay, Aaron, and the last, well, not last one.
-1.
-1, and we're going to evaluate
-1 plus 2 is 1 minus.
So f of 1 is also 1, and then the -3 is.
Yeah.
And last one, go ahead, Misha, what do we got now?
0.
0. And you can kind of see the pattern emerging. F of 0 plus 2 is f of 2. F of 2 is -3 is. Oh, okay. I think we ought to do another one of these. Let's do. What did I have in mind? How am I doing on time? That's great. So let's do a x and negative f of x plus 3. Oh, deciding that first x, I think, is the hard part. Remember, we can only evaluate f at these values. So that means what we end up here, what we end up with, we want this to be a -2. We want, so it's going to be -5. Crazy, crazy, crazy. So when we put in -5, we evaluate f of -2. F of -2 is 5, and then we multiply that result by -1, so it becomes a -5. Oh, a twisted path. Katie, what's the next one?
-4.
Good. And what we evaluate is f of
1.
-1. And f of -1 is,
3.
and that gets multiplied by -1, it becomes -3. All right, Colby, what's next?
-3.
Which we evaluate f of
1.
f of 0, and f of 0 is,
-1.
which gets multiplied by -1 to become, that's where you're jumping. Is that okay? All right, Heidi, what next?
-2.
Okay, which means we evaluate f of,
1.
which is,
1.
which ends up being, nice. And the last one, what do you got, Aaron? What do you plug in?
F of 2. Oh, sorry, -1.
Good. And it becomes f of 2. Okay. All right. Let's do a different one. I'm going to give you a function as a graph and see what we can do with it. We'll go back to, here is going to be our original. Oh, we're going to do this quickly. So we have 1, 2, -2, +2 in the x, +2 on the y, -1 on the, also on the y. And our function is going to look like this kind of triangle like looking thing here, and then a steep one over there. That's our y equals f of x. So let's see if we can graph. Let's do y equals -f of x first. So I'm the same graph, but I've got many colors of chalk. Good luck if you're in pencil. You might have to do a separate graph, or you can make it dotted dashed or whatever. So with your finger in the air, show me what negative f of x is going to look like going from left to right. So this part gets reflected over the x. So that part that went down to -1 is only going to go as high as +1. So it's going to look like this. And the part on the right that goes all the way up to 2 is now going to go all the way down to -2 when we flip it in the x. Okay, in the blue, we're going to do y equals f of -x. All right, take a look. What, with your finger in the air, is that going to look like going from left to right? Yeah, okay, good. So the tall one goes to the left, so it's going to go all the way up to 2. The short one gets reflected over there, so it's going to only go down to -1. Is that okay? All right. Well, I didn't get my translations in, but we'll try those another time. I think I better wrap up there. Okay, everybody clear on what's going on tomorrow? You're going to come to the cafeteria. We're going to start the ball rolling at 8 o'clock.